So the Department of Engineering is very broad-based in terms of its technical coverage. We have aerospace, civil, mechanical, materials engineering and manufacturing. And some key players are involved there, for example Jaguar, who help us with the techniques and the manufacturing design issues related to automobile manufacturing. But let me concentrate perhaps a little bit on our aerospace. The collaboration we have with BA Systems to do with simulation of aircraft operations and the concept of virtual engineering. A good example is in the development of the European civil tilt rotor, where we at Liverpool are the custodians of one of the key models, the simulation models used throughout Europe to develop this aircraft. And we can explore ideas with this model and with this simulation on our flight simulator with test pilots and look at ways in which this aircraft can be operated safely and more effectively.
It's a basic cockpit that's used for all sorts of new things, trying out new ideas, comparing things. The advantage of this sort of thing is that you can do it and you can do many hundreds of different types of flight control in a comparatively short period and of course in total safety.
You have a really accurate, what we call high fidelity simulation, and you can predict the future. And that's the way you reduce costs and timescales of development and ultimately make better products. And I think that's why industry like to be engaged with us.
Selective laser melting is a solid free-form fabrication technique. It's essentially a layer-based rapid manufacturing method whereby we can take a solid model in a CAD system, so in virtual reality, and turn it into real reality. We use the technique for a number of different projects. These projects may be industrially funded or they may be fundamental research projects. This jawbone, for instance, this is a good example of maybe a medical component, and we will be working with implant manufacturers and implant developers to construct this type of device to increase the performance of existing orthopedic implants. We've recently branched into the manufacture of various types of electronic components. In the simplest case, we're looking at the manufacture of heat exchangers and the manufacture of heat sinks for things like chips. So we're able to put our metal components on top of chips. We like to interact with companies, and we like companies to interact with us. We work with large enterprises such as BA Systems. We work with smaller enterprises, but quite relatively famous enterprises, Formula One teams, etc., to try and reduce weight. We do development work for designers, so single people, who just might have come up with a groundbreaking idea that can be produced and developed using this sort of technology.